And we substitute in 1 for y. Now we have x is equal to 1, a minus 4 times 1 is a minus 4. 1 minus 4 is a negative 3. So an ordered pair will be negative 3, 1. And that is our answer. Now our objective 2. We want to use the substitution method to identify systems with no solution or infinitely many solutions. Okay, example 5. Solve the following systems using substitution. Okay, if you notice in both of these equations here, we do not have a variable by itself. We have to determine which equation that we want to get the variable by itself. I would think that the first equation, or you know what, the second equation isn't bad either. I probably would go with the second equation. This 2x plus y equals 5. So now let's take this equation here. We have this 2x plus 5, 2x plus y equals 5. Now, we want to get y by itself, so we subtract 2x on both sides. And now we have y equals negative 2x plus 5. Now, we could put this in the other equation, substitute in negative 2x plus 5 for y. So we will have 2 times negative 2x plus 5 is equal to 8 minus 4x. 2 times negative 2x is a negative 4x. 2 times 5 is 10. Is equal to 8 minus 4x. Now we want to get all the x's on one side. So let's move the x from the right to the left. So we will add 4x on both sides. Negative 4x plus 4x is 0, plus 10 is 10. And then we will have equals 8. Negative 4x plus 4x equals 0. Now we have no more variables left, but we know 10 does not equal 8. So our answer here would be no solution and inconsistent. And that would be our final answer for this problem. Now again, our answer was no solution and inconsistent. Now, that is because we had one number that's not equal to another number. That's how we get the no solution and inconsistent. But if these two numbers were equal to each other, whether it was 0 equals 0, 9 equals 9, or so on, it would have been infinitely many solutions, and it would have been dependent. Now we come to objective 3. Solve linear systems by the addition method. Use the addition method to solve. It says add the two equations together. What happens? So if we take x plus y is equal to 5 and x minus y equals 1, and we add these two equations together, x plus x is 2x, a plus y and a minus y is 0, and that equals to 5 plus 1 is 6. Now, we divide each side by 2, and we get x equals 3. It says now take the value of x we found and plug it into one of the original two equations to find y. So because there's more space up here, I'm going to use this to substitute in 3 for x. So I'm going to take the top equation. We add x plus y equals 5. We will add 3. We substitute in for x plus y equals 5. Subtract 3 on both sides. And y is equal to 2. Now it says, what is the solution to this system? It's 3, 2. You could check that 3 plus 2 is 5, and we know 3 minus 2 is 1. So this is the solution. Now we come to example 7. It says, use the addition method to solve. It says, in this system, directly adding a two equation only gives us a new equation. What can we do to make a variable eliminate when the equations are added? Now, this is what I'm going to do for the sake of time. All you have to do for this problem here is to determine which variable you want to get rid of. It doesn't matter which one. Okay, let's say we want to get rid of the x's. Okay, what we would need to do is this here. We would have to make sure that they have the same coefficient but with opposite signs. Okay, so now we have x plus 3y equals 7. and 3x minus y equals 1. Now, the coefficient of x and 3, the coefficient of x is 1. The coefficient of 3x is 3. We have to find a common coefficient of 1 and 3, which is 3. But we want to make this become negative instead of staying positive. So we will multiply this equation here, this whole equation, by negative 3. So now, this will read as negative 3x minus 9y equals a negative 21. And we will bring this over here. 3x minus y equals 1. Now, like in the previous example, we will add these two equations together. Negative 3x plus 3x is 0. Negative 9y minus y is a negative 10y. And negative 21 plus 1 is a negative 20. We will divide each side by negative 10. And y is equal to 2. So now we have to take one of the two original equations and substitute in 2 for y. So I would take the top equation. So we will have x plus 3 times 2 is equal to 7. So we have x plus 6 equals 7. Subtract 6 on both sides, and x is equal to 1. So our ordered pair here would be 1, 2. And that will be our final answer. Now on the next page here, we have the box telling us the steps to solve a linear system by addition. Now I'm not going to go through all the steps, but the main thing is that you need to set both equations up in standard form, the ax plus by equals c. And like we said before, we have to determine which variable we want to eliminate. And then what we would do is, like I told you with the 1 and 3, we will find the least common multiple of the coefficients and then take the opposites of those coefficients. And then we will add the equations together, and then we will use our answer to go back and solve for the other variable. Now this method is also known as the elimination method. So let's try it again. We have that both of these equations are set up in standard form. We had 3x plus 4y equals 9 and 2x plus 5y equals 13. Now the question that we have here is what variable we want to get rid of. Since we got rid of the x's the last time, this time I want us to get rid of the y's. So we look here at our y's. We have 4y and 5y. We know the least common multiple of 4 and 5 is 20. So let's take this 3x plus 4y is equal to 9, and 2x plus 5y is equal to 13. Now again, our least common multiple of 4 and 5 is 20. So we ask ourselves, 4 times what is 20? Is 5. So we will multiply this equation by 5. And then down here, 5 times what is 20? We'll multiply by 4. But if you notice, both of these have the same sign. So we have to make one of these negative, so we will have the opposite sign. It doesn't matter which one. I'll just do it on the bottom. Okay, now we're going to multiply these. 5 times 3x is 15x. 5 times 4y is 20y. And 5 times 9 is 45. Negative 4 times 2x is a negative 8x. Negative 4 times a positive 5y is a minus 20y. And negative 4 times 13 will give us a negative 52. Now we add these two equations together. 5x minus 8x is a negative 3x. These 20s cancel each other out to 0. And it equals to 45 minus 52 is a negative 7. Now, we divide each side by negative 3. And x is equal to a positive 7/3. Now we have to go back and substitute this value into the x value. Now, if I was doing this problem, which I am right now, but speaking as a student, I would pick the equation that will give me less trouble with these fractions. So I would think that the 3x, because this 3 in the denominator and this 3 as a coefficient would simplify out, I would do this first equation here. So I would take 3 times 7/3 plus 4y is equal to 9. These 3's will simplify out and leave you 7. So we have 7 plus 4y equals 9. We will subtract 7 on both sides. And you have 4y is equal to 2. Now to get y by itself, we need to divide each side by 4. And y is equal to 1/2. So now our ordered pair is 7/3, 1/2. And we're done with this problem. Okay, now we come to example 9. It says solve the following systems using the addition method. Now, as I look here, we've already did the least common multiple of 5 and 4. So we know that's 20. So I think I would use that since I already know that the coefficient of these y's must be 20. Now, we know we would multiply this by 4 and the bottom equation by 5. Now, one thing that I like about this as well is their signs are already different. So all we have to do is just multiply by the positive value. So 4 times 2x is 8x. 4 times 5y is 20y. And 4 times 2 is 8. Now we take 5 times x, which is 5x. 5 times a minus 4y is a minus 20y. And 5 times a negative 12 is a negative 60. Now we add these two equations together. 8x and 5x is 13x. These y's will simplify out, and it equals to 8 minus 60 is a negative 52. We divide each side by 13, and x is negative 4. Now we substitute in negative 4 for x. I would do the top equation. So we add 2 times negative 4 plus 5y equals 2. 2 times negative 4 is negative 8 plus 5y is equal to 2. Add 8 to both sides, and you will have 5y is equal to 10. Divide each side by 5, and y is equal to 2. So our ordered pair here will be negative 4 for x and 2 for y. Now example 10, it says solve the following systems using the addition method. This time we're going to simplify out the x's. So the least common multiple of 6 and 9 is 18. So we know 3 will multiply by the first equation. And we know that 2 will multiply by the second equation. Okay, so now we multiply these values. That will give us 18x minus 12y equals 30. This will give us a negative 18x plus 12y equals negative 30. Now for some reason, these values are disappearing, but I rewrote them in. Okay, so we have 18x minus 18x is 0, negative 12y plus 12y is 0, and 30 minus 30 is 0. So our answer here is infinitely many solutions and dependent. And that is our final answer. Whenever you have no variables left and the number is equal to itself, this is the answer. Now this is infinitely many solutions infinitely many solutions and dependent. I don't know what is happening, but this is it here. Infinitely many solutions and dependent. And that is it.